If the moon were truly dead, why does it still tremble in the dark? If these unusual signals didn't come from speculation, but from measured data, what does that tell us? And what if the most confronting truth isn't somewhere far out in space, but in how little we understand what's right beside us? For thousands of years, the moon has quietly lit our nights, steady, familiar, seemingly unchanged. Yet deep within scientific records lie signals that never fully faded. Subtle vibrations, unexpected reactions, numbers that have caused even seasoned scientists to stop, reflect, and question long-held assumptions. This isn't a story about conspiracy or fear. It's a calm exploration of uncertainty, and a reminder that knowledge always has limits. Stay with us until the very end, because the final question may quietly reshape the way you see the moon. And if you value thoughtful journeys into the universe, subscribe and join us. You're always welcome here. For much of the 20th century, science viewed the moon through an almost unquestioned conclusion. It was a dead world, with virtually no atmosphere, no liquid water, no life, and most importantly, no meaningful geological activity. The moon was believed to have long since fallen silent. It was described as a kind of cosmic fossil, an unchanging satellite that existed only to reflect sunlight and preserve the scars of ancient impacts. Craters that had remained untouched for billions of years were taken as clear evidence of a world that had stopped evolving far into the past. This belief was not without reason. It was built on early observations, mathematical models, and constant comparison with Earth, a planet alive with heat, motion, and transformation. Compared to Earth, the moon seemed too small, too cold, and too quiet to be considered active in any meaningful sense. And over time, that assumption became accepted truth. The questions faded, expectations disappeared, until scientific data itself began to quietly suggest that perhaps we were too quick to call the moon a silent world. When the Apollo missions landed on the moon, their purpose went far beyond planting flags or collecting rock samples. The astronauts also left behind sophisticated scientific instruments, most notably seismometers. Their task was simple: to listen to the moon. For years, these instruments quietly recorded every vibration, every subtle movement occurring on and beneath the lunar surface. The result was thousands of pages of raw data, seismic charts, waveforms, and long sequences of signals gathered over extended periods. All of it was archived by NASA. However, not all of this data was analyzed in depth at the time. Technology was limited. Scientific models were still evolving. Many signals were recorded but couldn't be clearly explained, and so they were set aside. Not because they lacked importance, but because we lacked the tools to understand them. Over the decades, much of this information faded from active study. It wasn't hidden, it wasn't erased. It remained quietly preserved, waiting for future generations with better technology and a more open perspective. And when researchers finally returned to these old numbers, a strange realization emerged. The moon may have been speaking all along, and only now are we beginning to learn how to listen. What the Apollo seismometers recorded next was something few scientists expected. The moon was shaking. These lunar tremors, now known as moonquakes, were fundamentally different from earthquakes on Earth. On our planet, seismic activity typically builds, releases its energy, and fades within seconds or minutes. On the moon, however, these vibrations behaved very differently. Some lasted not minutes, but tens of minutes, slowly rising and falling as if the moon itself were resonating. Even more puzzling was their cause. While some moonquakes could be linked to meteorite impacts, many others occurred without any detectable external trigger. No impact, no collision, no obvious force striking the surface. And yet, the moon continued to tremble. The data revealed several types of moonquakes, shallow ones near the surface, deeper ones originating far below, and thermal quakes caused by extreme temperature changes. But it was the deep moonquakes that raised the most questions. These events appeared to originate hundreds of kilometers beneath the surface and followed repeating patterns, almost as if driven by internal processes rather than random chance. For decades, these findings sat uncomfortably alongside the old belief that the moon was geologically dead. A silent world should not behave this way. A frozen interior should not produce rhythmic, long-lasting seismic signals. So a new question quietly emerged from the data, one that science could not easily dismiss. If nothing is striking the moon from the outside, then what exactly is moving within it? That question marked a turning point, because a world that trembles even subtly may not be as lifeless as we once believed. As scientists examined the Apollo seismic data more closely, a deeper problem began to emerge. The moon's internal structure appeared to be far more complex than previously assumed. For a long time, the moon was thought to be nothing more than a cold, solid block of rock, its interior fully frozen billions of years ago. Yet the way seismic waves traveled through the moon told a different story. Some waves did not fade as quickly as expected. Others reflected at unusual angles, suggesting that the interior may consist of multiple layers with distinct physical properties. Modern models now suggest that the moon may possess a small core, possibly made up of both solid and partially molten material. At first glance, this sounds familiar. Earth also has a core. But the similarity ends there. Earth's core is large, intensely hot, and drives a global magnetic field. The moon's core, if it exists, appears to be far smaller and far weaker, behaving in ways science does not yet fully understand. It is precisely this contrast that forces researchers to remain cautious. The unusual seismic signals are not sufficient to confirm that the moon is geologically alive in the way Earth is. Yet they also do not fit the image of a completely inert, lifeless body. Rather than drawing firm conclusions, science is left with an open possibility. Within the moon, slow and subtle processes may still be taking place. Faint, restrained, but real enough to leave traces in the data. And it is these faint traces that push human curiosity to its peak. Because sometimes the most important step in discovery is not finding an answer, but having the humility to admit how much we still do not understand. One of the most intriguing details emerged when scientists revisited the Apollo data and examined how the moon responds to vibrations. When lunar modules or spent rocket stages struck the surface, the seismometers recorded something unexpected. The moon continued to vibrate for a remarkably long time, almost as if it were ringing like a bell. On Earth, vibrations caused by impacts usually fade quickly as energy is absorbed by air, water, and softer geological layers. The moon, however, is very different. With no atmosphere, no oceans, and a dry, rigid surface, seismic energy is reflected and transmitted in unusual ways. As a result, these vibrations can persist for tens of minutes. Some astronauts describe the phenomenon using familiar language, likening it to the sound of metal resonating. Not because they heard sound in the conventional sense, but because the seismic signals produced a prolonged rhythmic resonance that felt strikingly unnatural. From a scientific perspective, the most widely accepted explanation is that the moon behaves like a dry, solid body with very low energy loss. Still, certain aspects remain unclear. Not every vibration can be traced to an impact. Not every signal fits neatly into existing models. For this reason, researchers maintain a cautious stance. The moon's ringing is not evidence of anything mysterious, but it is a reminder that the structure and behavior of our nearest celestial neighbor are still not fully understood. And it is within that uncertainty that human imagination naturally expands, not to escape science, but to continue asking the right questions. As observational technology has advanced, the moon's mysteries are no longer confined to its interior. Increasingly, they are revealed directly on its surface. Modern orbiters have detected localized magnetic regions, small and scattered, yet strong enough to deflect the solar wind. This is especially puzzling, given that the moon lacks a global magnetic field like Earth's. Alongside this, scientists have identified unusual dark and bright regions with reflectivity that differs sharply from their surroundings. Some bright areas appear as delicate, swirling patterns across the surface, unconnected to any obvious impact craters. Their shapes challenge traditional geological models, which largely rely on meteorite impacts and slow surface weathering to explain lunar features. These anomalies are not entirely new discoveries. However, only with high-resolution data has their true complexity become clear. Current scientific hypotheses suggest they may be linked to magnetized minerals within the lunar crust, or to remnants of ancient processes that occurred when the moon was far younger. Yet no single explanation has been universally accepted, and it is the coexistence of local magnetic fields, unusual surface regions, and shapes that resist easy explanation that deepens the mystery, reminding us that despite centuries of observation, much of the moon is only now beginning to be truly seen. Despite decades of study, a quiet truth remains. The data we have may still not be enough. Many of the moon's signals are incomplete, fragmented by the limits of older instruments and short mission lifespans. Some measurements captured moments in time, but not the long rhythms needed to fully understand what was happening beneath the surface. Future missions promise sharper tools, longer observations, and new perspectives. More sensitive seismometers, deeper drilling, and continuous monitoring may finally reveal whether the moon's subtle activity is fading or simply slow. Yet, even with better technology, answers are not guaranteed. Because the greatest challenge may not be the moon itself, but our expectations of it. We often assume that understanding comes quickly, that data leads neatly to conclusions. The moon reminds us otherwise. It sits close to us, familiar and constant, and yet, in many ways, still unknown. And perhaps that is its quiet lesson. That true exploration is not about certainty, but about the patience to keep asking questions when answers refuse to arrive. The moon is still there, quietly circling the Earth, just as it has for billions of years. Yet the deeper science takes us, the more we realize that every answer gives rise to new questions. Human knowledge continues to expand, but so do the mysteries that surround us. Perhaps the most important point is not whether the moon is truly alive or not, but what it reminds us about the limits of our understanding and the humility required when facing a vast universe. If you value journeys of exploration like this one, consider subscribing and continuing the journey with us. And before you go, ask yourself one final question. How much do we really understand about the world closest to us?